Next, we see Michael Granfield's choreography system written in Apple Sprite logo and his preliminary explorations in Q logo.
I'm Michael Granfield, and the project that I'm working on is to develop a choreographer's workstation. We're going to take a look at two of the aspects of the research that I've been doing. Let's take a look at the Sprite logo system. This system lets me choreograph for several figures at the same time and allows me to give each figure its own role. Here are all the shapes I designed to give the sprites a movement vocabulary. After designing this system, I realized that an object-oriented language such as Q logo would enable me to move beyond the limitations of sprites and to create special dancer objects. The principal focus of my research in Q logo has been to develop a model of human movement based on a description of musculoskeletal behavior. Here is a look at the Q logo code which describes this dancer object. A dancer is a kind of human. A human has a musculature and a skeleton. Upon coming into existence, a skeleton will have these parts. Now we see a dancer performing.
We have constructed mechanical devices. One of them is a marionette machine, described by Mark Gross. His programs are written in Q logo. The hardware was built by Doug Milliken.
The limbs of this puppet are connected by strings that wind over pulleys and onto motors that are mounted beneath the stage. I control the movement of the motors with a computer. I'll show you that now. Procedures that we've built tell the puppet to lay down, get up, and to walk.
Max Pahansky demonstrates a force feedback joystick. This joystick can push on your hand under program control. Doug and Peter Milliken built the joystick with Max's help at the suggestion of Marvin Minsky.
This is the force feedback joystick. It's like a normal joystick because it can inform a computer or video game what the position of its handle is. It also contains two motors, one for X and one for Y, that push on the joystick handle in each dimension, thus producing a force in any desired direction and amount. We've written a little maze program that lets you find your way around. That little square is you, and you can move around on the walls. You can feel the bumpiness of those steps. And this one simulates a heavy weight on the end of the stick. We also wrote this fishing game. It's got three tactics. It wiggles, and it will jerk sometimes, and sometimes it'll just play dead. Last gasp, I hope. Yep, you just caught it.